Okay, slide that to the side. Wait, let's see. How do I get that? Okay, perfect. All right, so section 4.1, part 2. Section 4.1, is that maybe a little too high? Okay, no. Part 2. We're officially doing integrals. We don't really get to this till Monday, but it kind of, so our word problems, our book, you know, kind of is jumping ahead to try to tie everything together. But integrals, and we'll officially kind of show this more on Monday, directly correlates to antiderivatives. And like I said, we'll tie that in a little bit more with the word problems, and then we'll tie it in again on Monday. Okay, but we kind of start thinking about that. And what else does integrals find us? We're so kind of together, right? What are these? Since those are the same thing, those are literally the same thing, antiderivatives and integrals. It finds us area under the curve. Area under the curve. And so what we're doing today, yesterday and today, is we're literally approximating the area under the curve using rectangles. Okay. And that's called, we're just approximating using rectangles. That's called Riemann sums. You can use different shapes. So in Calc 2, we use trapezoids and parabolas, but for us, we're just using rectangles. We're breaking the area up into smaller rectangles. If we find the area of all the smaller rectangles, then we found the area under the curve. Let's reference this sheet. You guys should have this. Maybe even pull out yesterday. Yesterday's kind of hard because I didn't have that. I kind of like this guy. We are approximating the area, let me do it in red, under this curve. N, what's N from yesterday? Does anyone remember? N is your number of rectangles. Okay? N is your number of rectangles. And notice these rectangles are all touching on the left side of the rectangle. The left side of the rectangle is touching the graph. Okay? What's touching over here? The right side. You can even see it really good right here at the back. At this last one, the right side is touching. Notice the left side is not, but that's okay. This is the right side. So this L and R, which is also on your homework, L means you're doing it with left side. Okay, the L is the left side. We'll write that in our notes. And then R is the right side. Okay. Now we are approximating the areas. So when we do 10 rectangles, and we do it touching the left side of the rectangles, we get an area of 0.285. That same area from here to here, we're finding this area right here, okay? If I do it from the right side, I get 0.385. Okay? So remember, we are just approximating. So these two numbers are approximating the same area, just with different rectangles. Does it make sense that with different rectangles, it's going to produce different answers if we're approximating? What happens when we change it to 20 rectangles? All of these numbers are approximating the same area under the curve. But when I go to 20 rectangles from the left side and the right side, these are the answers I get. And you can see as I increase my number of rectangles, these two numbers get closer to each other. And this side is always a little bit smaller, and this side is always a little bit bigger. Okay. Now, how many rectangles do I have here? 1,000. Okay. Now, with limits, we can say as my number of rectangles heads to infinity, the more and more rectangles I get, I'm going to head to the exact answer. And we're going to see that when this is infinity, the area under this curve, now look, I have 0.3328, and here this is 0.338. Eventually, it's going to be 0.3 repeated. We're going to be able to prove that it is 1/3. But just approximating is pretty good. And actually, if you use midpoints, it's actually really good. I wish they did a third one with midpoints. We'd be able to see the 1/3 right away. Yeah. You could, yeah, you definitely, that's another way. Sure, you could do, well, what we're going to do is we're going to average the left and right side to get the midpoint. So we only have to do the problem once. But yeah, you're right. Otherwise, could you do the left side, the right side, and average them together? Absolutely. Yeah, I like it. Because again, these are all averages anyways, right? To get the exact value, we're going to do algebra, we're going to talk about limits, and then we're going to talk about shortcuts. Yeah, but yeah, I like it. Yeah, go ahead and just average those two together. Beautiful. It's good. Okay, so put that off to the side. We'll do the word problems in a minute. Did we see yesterday's? I don't want to spend too much time because we did it yesterday, but it was kind of hard to see with the thing. Here's our curve on yesterday's. I want to approximate the area under that curve. If I only do 2 rectangles, you know, do we see how there's a gap here? But there is a little bit above. So some of this is getting filled in. Here it is with 4 rectangles. Notice this is the exact same curve. Now I'm closer, right? Because maybe this could go like in here, and this at least could go up here. So I'm getting closer. See, the more rectangles that we do we see now how there's even less? There's like space here, but this is going to overtake that. Okay, and then here you get even closer. Okay? The more rectangles, the closer you're fitting to the curve. Okay? All right, and then flip it over real quick. Do you see how, like this one, all the rectangles go to the graph on the left corner. Notice this right corner is not touching the graph, and that's okay. We're fitting a rectangle, so we can only fit one side to the graph, right? So this is where it's left side. Here, what's happening here with our lovely cosine? This one is, do you see how we're not doing either end of the rectangle? We are doing the midpoint. And do you see how midpoint, this part can just fill in right there? This part would kind of fill in there. And then here one last time where you can see the more rectangles, the closer you get to the curve. Okay, this is using left and this is using right. All right, so let's actually do one. Let's do this one. Let's find the area. Okay, let's make sure. I want to make sure it's semi-straight. Okay. Find the area. Oh, let's write this down. What does L6 mean? What does L6 mean? 6 rectangles, all from the left side. Okay, so 6 rectangles, left side. Which kind of makes sense, but if we don't say it, sometimes you're kind of like, all right, and so we could just do, let's do R. Usually we keep them even. It's just kind of nice. It doesn't have to be. R4 would mean 4 rectangles. And then the R means right side. And then we could do M. I don't know. We could do 5. M5, that would be okay. That would be 5 rectangles going to the midpoint. 5 rectangles, you get the idea. 5 rectangles, and then M means midpoint. All right, so just so that those are written down officially. All right, so we'll write the directions and then I'll slide it up. Find the area. Find the area under y equals, or remember it's the same as f of x, so it could be either one. I find they like f of x for this problem. I think our book does y. I don't know. Or maybe I copied this from a different book that did y. X, the square root of x plus 6. and then from -2 to 3. And then let's say using R5. So slide that up. Okay, so it does help to know what this graph is. If you don't know, then we'll just kind of have to do, you'll just have to do like the x-axis. Does anyone know what the square root of x plus 6, what that graph looks like? It actually moves it 6 places that way, and then it curves like this. So it's kind of like half of a parabola on its side, and if it's plus 6, it's actually starting back 6. Okay, so, and I don't know why, maybe because this is the one few times, most of the time we do positives, but our book is doing negatives, so we'll do a negative. So from -2 and then to 3. And I might draw this a couple of times because I want you guys to see. From -2 to 3, we are approximating this area. This is our start, this is our stop, this is our A, this is our B. So that's the area that we want to approximate, from -2 to +3. Now, eventually, starting even tomorrow, we're going to be able to come up with the exact answer, but that's not always the case. So it is good to learn Riemann sums because finding the exact area can be tricky. All right, so let's try it again. This time I'm going to open it up. So here's my 0. I'm just going to do -2 here and then 1. And so I know that it's -6 somewhere over here. So it kind of curves like this. All right, so that is my f of x. Maybe I put a little too close. All right, so we are going to do, what does R5 mean? 5 rectangles from the right. 5 rectangles from the right. So how do I know the width of each rectangle? The width of each rectangle is b minus a divided by n. That is and the width, don't let delta x scare you. Delta x just means the width. And we even use that, we change that to dx. Width of the rectangle, dx. And that's the width of rectangle. Because what do I need in order to find the area of a rectangle? Length times width, right? The width times the height, or the width times the length. Okay. So B is 3, that's where I end. A is, and these guys are called, I talked about this yesterday, these are called limits. Don't be intimidated by the word limits, they're just called limits. B minus A, now be careful here. B minus, and then A just happens to be negative, divided by n, which is your number of rectangles. This is n. So that gives us 5/5, which is 1. So the width of each rectangle is 1, which turns out really nice. Our book is pretty nice. Do we see how this would be 1, 2, 3, 4, 5? There's our width, so that's kind of nice. They're using the integers. Beautiful. So if my first rectangle is a width of 1, and I'm going to the right side, I go up to the right, and then I just have to come over and down. And the area of that triangle would, the area of that rectangle would be width, which is 1, times the height, And the height is the y value when x is -1. The y value, which we write as f of -1. I am starting at -2. How come I did not do f of -2? I'm starting at -2. How come I didn't do f of -2? Boom, got it. Beautiful. Don't forget, I am starting at -2, but I'm taking it from the right side. So that means I go over and then I do the right side, -1. Beautiful. Okay, good. And then I'm just going to add to it the width of 1. And then I want my height of the rectangle is the y coordinate. The height of my rectangle is the y coordinate. So I want to show that I want, and what is this x value? 0. So I want the y coordinate, so that's my height when x is 0. All right, then my next rectangle goes here, a width of 1. I just add the areas. We just add the area of the rectangles together. So my width is 1. My height is on the right side. I stop when I get to the graph. Okay. And so that is, maybe I didn't connect this. All right, so where is that height? When the x value is 1. Now we just keep going. Width is 1. Height is the y value when x is 2. And then we got, let's draw it across. Okay. Sometimes my graph maybe isn't that good, but that's the point too, right? Hopefully my rectangles get pretty close to the graph. And then my width of 1 and my height is on the right side. So when x is 3. And we talked about yesterday, if this, let's say this was 4, a width of 4, you could actually factor that out. A 1 you don't even need to worry about, but technically you could factor that out and then do f of -1 plus f of 0 plus f of 1 plus f of 2 plus f of 3. So keep in mind, you can even factor this guy out. The 1, you don't even need to worry about it, but otherwise you could take the, so you only have to do it one time. Just don't forget, I like factoring it out, but just don't forget. Make sure you write it down. These problems are very long, so if it is any other number besides 1, make sure you write it down so that you don't forget it. Okay, now how do we find f of -1? How are we going to find that? Well, we got to take -1 and plug it in. And so we have the square root of 5. Plug in 0 plus the square root of 6. Plug in 1 plus the square root of 7. Plug in 2 plus the square root of 8. And then plug in 3. You could write the square root of 9. You could write 3, but since all these other ones are just square root of 9. So you have to do the f function, plug it in. That gives you the y value. The y value is the height. So to get the y value, you have to plug it into the function. It gives you the height of the rectangle. And then it's just a matter, then you would add those up. So square root of 5 plus square root of 6 plus square root of 7. You get the idea, right? Square root of 8. And then I could just do plus 3 since I know what that one is. And I should get, okay, there it is, 13.1597 technically times 1. Again, you only have to worry about the 1 if it's not a width of 1. And so that would be the 13. Oops, 1, what was it, 1, 5, sorry. Okay, so what is this number? 13.1597. Area under this curve, right? This red, an approximation for the area in red up here. Notice too, we talked about yesterday, it always goes, the x-axis is the stop. Okay. It is from the curve to the x-axis, or from the x-axis to the curve. Okay, we'll talk about what happens if it goes below the curve. Come back Monday. I'll be viewing systems. All right. Okay, let's see. Let's do the same one. So let's do that same one. F of x equals square root of x plus 6. But let's find area using M5. And let's do, we're still going to do the same thing. So we're still going to do from, what was it, -2 to 3. So we are literally finding the exact same area. How come our answer is probably going to be a little different? Say that again. Okay, yeah, but why in math, if we change that, why are we going to get a different area? Because we are only approximating. Do we see that? So because we're changing stuff, the approximation is going to be a little bit different. Does that make sense? And when we do it mathematically, algebraically, we're going to get the exact answer, and that's going to be the exact area. Okay? Maybe we'll even come back to this, and we'll see how close our approximations are. Right. But we're finding the exact same thing, and yes, because we're changing it, we're going to get a different answer, but that's because these are all approximations. Does that all kind of make sense? Okay. All right, so let's take a look at that same graph. We're going from -2, this is 0. Okay. So we got that same graph 2. Okay, so curves like this. All right, so we have, as far as, again, how do we find, I think we'll have time maybe to do one more. Yeah, we should have time to do one more. How do we find the width of each rectangle? Well, if we're doing 5 of them, and from -2 to 3, does it make sense that we've got 1, 2, 3, 4, 5? Some of you might be able to just kind of visually see it. Remember, if we want to know for sure the width, which is dx or delta x, b minus a divided by n. Okay, we'll just watch your negatives on this one. B is 3, the end, minus in the formula, then a is -2, and then n is your number of rectangles. This is your n, this is your a. And so sure enough, we do get a value of 1. Okay, so I know that I'm going to start here at -2, and I know that my width of my rectangle is 1. But I'm not going to go up to the left. I'm not going to go up to the right. My height is going to be the midpoint. So on this side, it's a little bit over, and on this portion of the rectangle, it's a little bit under. That's why the midpoint turns out to be so nice. So I know my width is 1 times my height. I'm going to get my height from the y, but how do I figure out where I'm at? You simply average them together. -2 plus -1 divided by 2. Or some of you might just say, hey, I know what's halfway between -2 and -1. Yeah, -3 halves, -1.5. Exactly. So if you can figure it out, great. If not, let's do it right here. You just simply average them together. -2 plus -1 divided by 2. Gives you the -3 halves or the -1.5. So it's 1, and then f, and we want the height when x is 1.5. All right, how about this next one? I'm not going on the left side, I'm not going on the right side, I'm going up the middle. So that means a little bit above and a little bit below when I finish out my rectangle. Where is that middle though? Some of you might be able to look at it, right, and say, negative 1/2. If not, so 1 is my width, negative 0.5 or 1/2, either way is okay. If not, you average negative 1 plus 0 divided by 2. There it is, the negative 1/2. All right, same thing, plus my width is 1. I want my height up the middle, a little bit over, a little bit under. So my middle is 1/2. If I don't know it, or I'm just, my brain isn't working, I average from 0 to 1. I average 0 plus 1 divided by 2 takes me to 0.5. We're on our way. 1, 2, 3. We need 2 more rectangles. Next one has a width of 1. My height is up the middle, a little bit over, a little bit under. Where am I there? This is 1, this is 2. I'm at 1.5. If I don't know for sure, it just seems too tricky. Divide by 2, right? Add them up, divide by 2. I gave you a trig problem. I took that one off. I'm like, we don't need that today. So that would be what? F. This is my x value is at 1.5. I still have to go find my y, but I know my x value is 1.5. And I think we could probably do the last one. Remember, it's 1 and then times 2.5. Halfway in between there. And again, if you have to average, that's okay. Midpoint will always be the average. Okay, and then we just go at it. Now, how do I get the ones I don't have to worry about? If I want to factor it out, especially if it's any other number, that's fine. How do I do f of negative 1.5? I literally put negative 1.5 in there. So that gives us what? Oh, I don't need that because I'm putting it in. I actually know the square root, right? The square root of 4.5. Plus, if I put a negative 0.5 in there, I should get the square root of 5.5. This one would be what? 6.5, 7.5, and then 8.5. Okay, and then just a matter of typing those in. I got something like 12, and I might have rounded each one of these, which I don't know why, but who knows. 12.6701. What did you get? Did you type it in?
Same thing.
Same thing? Okay, good, okay. Maybe I actually did it right. Okay, so this red, we got somewhere between 13.1, 13.2, and 12.6. Same area, but because we're using a little bit different method, and both of them are approximations anyways, but they're relatively close. They're in the ballpark. How could I make it more accurate? More rectangles. Yep, more rectangles. And I would stick with midpoint. Midpoint is usually pretty good. Midpoint, more rectangles, beautiful. If you want even more accuracy, calc 2, we add in different shapes. All right. What else? Let's just talk about, let's do this one. Let's do this one. It's not midpoint, but are we okay on midpoint if we only do one? Just average them together, because this one's a little bit harder. And if we don't finish, or you could just copy down my numbers, hopefully they're right, right? F of x is, what happens if it's x squared plus 3x? And we're going from 1 to 4. This time they wrote it kind of like that. Oh, and then find M of, oh no, we weren't going to do that one. Let's do L of 6. So now, if we don't know what, let me show you, okay, so let me show you what this graph looks like. But if you don't have a graphing calculator, it's gonna be a little bit harder, but I'll kind of show you how I do it even without looking what the graph is. This is a parabola, and it kind of goes like this. It's supposed to be even, maybe it goes out this way. That's actually pretty good if I erase that. Okay. For me, that's good. No laughing there. Are we okay though that it's this curve right here? It's kind of a parabola. And then we're going from 1 to 4, wherever 4 is. You can just kind of go. We're finding the area from the x-axis to the graph from 1 to 4. That's our goal. We're only approximating left side 6 rectangles. Left side 6 rectangles. So what I do is I'm going to just like blow this up. So I have this, I'm going from 1 to 4. So this is 1, 2, 3. Too bad I didn't ask for 3 rectangles. But how do I figure out then the width of each rectangle? Well, some of you might say, well, I can just figure that out. Fine, that's not a problem at all. Otherwise, delta x dx, all right, is b minus a divided by my number of rectangles, which is 6. B minus a divided by n. B, this is b, this is a, this is n. Oh gosh, 10 minutes. Okay, so b minus a divided by n. So that gives me 3/6, which is 1/2. Okay, and I love fractions. But if you want to go decimals, if it's 1/3, then you got to stick with that fraction because otherwise you're rounding, but we're approximating anyways, so we probably would be okay rounding. But for 1/2, if you want to do 0.5, that's more than fine. So that means my rectangle is only a half. And then how am I going to find the height? Am I going to touch the graph on the left side or the right side? The left side. So this is what's touching the graph. Like I said, this is how you're going to do it if you don't know the graph. I'm just going to put that it would be touching the graph on that side. All right, so my width is only 1/2. And then my height is going to be f of 1. I don't know the y value. I got to go figure that out, but I do know the x. I want the height when x is 1. All right, so now where does, I'm just do it in a different color. My next rectangle goes here, wherever it may be. I don't really know, especially if I don't see the graph. But my width is 1/2. And if I want it on the left side, it's going to be f of, what did you say? Yes, good. F of 1.5 or 3/2. Yeah, beautiful. Either one, both are okay. 3/2 or 1.5. Good. And then we just go, remember, we're only going a width of 1/2. Where's my height? My height is when x is 2. Okay, my height is when x is 2. Where am I at? Width of 1/2. I don't really know. I mean, my rectangle could be totally wrong as long as I understand that I need it where the height is on the left. And what is that x value? So this is 1.52. And so this is 2.5. Yeah, 2.5. All right, and then we go 1/2. As long as I understand that this rectangle correlates with this corner, and that is an x value of 3. And you kind of start to see a pattern. And then my last one, I always am like one short. Story of my life, right? All right. So that last one is 1/2. Now be careful. It is where the left is 3.5. How come I'm ending at 4? How come I'm not using 4? Because I'm doing left. So when I'm doing left, I don't use the end. When I'm doing right, I don't use the start. Okay, so just be careful on that. Okay, and then the only other, okay, so I'm going to pull out, I'm going to be able to make it because I'm going to pull out the 1/2, and then I'm going to do f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3. Finally, I catch a break, right? I fit it all on. Okay, so now just a couple, but then it doesn't fit on the screen. Oh my goodness. Okay. And there must be something wrong with my eyes. Nothing is ever like level. But you guys are like, yes, I know this. Okay. And my architect majors are probably like crying. All right. So now okay, so let me rewrite. My f was x squared plus 3x. If you're going to do it by hand or with a scientific calculator, you're just going to have to take your time. You're going to have to plug a 1 into both, okay, and get an answer. 1.5, you square it, then plus 3 times 1.5. So if there's a more than 1x, you're going to have to plug 1 into all of them and get an answer. 1.5 into all of them and get an answer, okay? Remember on the graphing calculator, okay, here goes this. Okay. Let's clear this out. Okay, usually I always miss one. Okay, I think this will work. But you go to y1, you type in your equation. Type in your equation. And then quit, go to your home screen, and you can actually do y1 and just put a parenthesis. What was our first one? 1 plus. Don't go to y2. I'm so used to doing Newton's method and going to y2. You just stay with y1. And what was it, 1.5? Okay, and you literally just put it in the parentheses. You can't see that first one as much, but do you see how? And you just keep going. y1, 2, y1, 2.5. Just put parentheses, just literally like we wrote it. Oh, yep, you're right. Thank you, thank you. I told you. There, then parentheses 2.5. Beautiful. Okay. And then I always forget where I'm at, but you can look on your notes. I think I only have 2 more, right? 3. Did I forget one too or no? Let's see. Did I? Yes? Yeah, I'm okay. We're not sure. You were doing 3.5. Okay, yeah, I saw it. Okay, let's see. Yes, okay, that answers. No, that's not my answer. Because don't forget it. Remember, on the ones, it's so nice, but on this one, you still have to take it times 0.5 or divide by 2. Either way, however you want to say that. So we could do times 0.5. So 37.6. So don't forget, you can even write it down in your notes. It was 75.25. But don't forget the 1/2. Oh, yeah, with that calculator, but it does work. Okay, no, going the wrong way. Oh, geez, that's it. I don't know, but now I know. Oh, great, now I broke it. On a Friday the 13th, I broke it.
Told you go slow today.
I called Dr. Drew. Oh my gosh, I really did. Okay, it just takes time. It's going. Okay. Patience is a virtue. You don't have patience. All right. Okay, so questions. All right, we didn't get to the word problems. That's okay. If we get to them, that's fine. Some of you might have to backtrack and do yesterday's lesson, and then so yesterday's lesson, you can do 100%. Today's lesson, I think there's 2 of these, and then there's 1 or 2 word problems. Don't worry about those yet. Like I said, they tie into Mondays anyway, so we'll see where we're at on Monday. Okay. Say that again. No, that's a good question. You can do today's homework, just not the word problem. So you could do, let's say you could do half of today. No, good question. No, that's a good question. Yes, today there's a few more of these. A few more where they give you the function. Let me say it like that. Yeah, a few more where they give you the function today. Those you can do. Good. All right. Good job, guys. Okay, remember, everyone's going to try at least 30 minutes, okay, over the weekend. It's cold. Grab a hot chocolate. Sit at that computer. Put a timer 30 minutes, all right? We're all going to ace this last test. Yes.
It'd be funny. It's like all these other ones are good.
No.